Hey guys, this is just a quick video to walk you through factoring a quadratic trinomial with a leading coefficient that is larger than 1. So, let's define those terms really quickly before we get started. So, x squared that you see right here, the descriptive word that describes something that has an x squared as the highest power is quadratic. So when I say quadratic trinomial, I mean that the highest power on x is squared. The trinomial part refers to the fact that there are 3 terms. And leading coefficient, we've actually talked about leading coefficients before, but it's the number that is in front of the highest power of x, and in this case the leading coefficient is a 3. So up until now we have been working on x squared plus 4x plus 3, factoring those, and they're quadratic trinomials, but their leading coefficient is 1. So today our focus is how do we go ahead and factor those where it's not 1, like a 3 or a 4 or a 2. Let's go ahead and dive in. We'll start off fairly simple, and we're going to look at this in 2 ways because we want to always be able to factor both ways. So the first step for us is going to be to set up an x factor much like we did before. Again, this is just a convention or a tool for us to use that's going to help us. It's not actually doing any math itself. So to put the number on the top, the multiplying number, I'm going to look at 20 and 2. If I multiply those two together, we get 40. And that's what I'm looking for to multiply. And then I'm going to look at this term for the addition term. So I'm going to put a 14 down here. So we're asking ourselves what 2 numbers are going to multiply to 40 and add to 14. And those 2 are 10 and 4. So what do we do with it? The goal of that x factor was to get us these 2 values, which are going to tell us what to split that 14 up into. There's lots of things that add to 14, but only 10 and 4 are going to help us unlock this puzzle. So I'm going to go ahead and put 10x here plus 4x. And the order doesn't really matter. So 2x squared and then 20 on the end. The next step is to ask what's common between these 2. So we're going to undistribute, or what we called factoring the greatest common factor. And for the first 2, that is a 2, because 2 times 1 is 2x squared. And 2 goes into 10 as well, 2 times 5. So I'm going to take a 2 out, and then also they have an x. So 2x times x gives 2x squared. And 2x times positive 5 gives 10x. Then we'll take a look at these second 2 over here. And the thing that's common with those is a 4. 4 times 1 and 4 times 5. So 4 times x is 4x, and 4 times 5 is 20. And these are being added together. So basically we just kind of broke up our expression into 2 pieces and factored out what was common. So I'm going to go ahead and write greatest common factor as the step that we took. From there, basically all we need to do now is combine our like terms. And in this case, x plus 5 and x plus 5 are like terms, so we're going to add those together. So how many x plus 5s do we have? From the first, we had 2x of them, and from the second, we had 4. So grand total, we have 2x plus 4 of the x plus 5s, and this is the factored form. What I mean by that is it's equivalent, or another way of saying the same thing as the first part. And just to make an annotation here so that we know what we did, we added like terms. We can also see factoring in a different way. And when we see factoring this way, we look at it in terms of a box, because really that's what we're doing is we're finding area. We want to find out what the dimensions of this box are so that the insides are 2x squared plus 14x plus 20. So I would start by writing the 2x squared here, and I'm going to put the 20 down here to represent the area. What I need to do is think about numbers that are going to multiply to 2x squared. So I'm thinking 2x, and I'm just trying stuff here. I don't really know this definitively. So 2x times x is going to give me 2x squared. And then I need to think about what's going to multiply to 20, which there's really honestly lots of things. So let's say I had no idea, and I would just write 2 and 10. If I multiplied those, then in this box is in the top right is going to be 2 times x, and in the bottom left I'm going to see 2 times 10, which is 20x. Together, these make 22x, but I need 14, so that means my numbers are really too big. Or maybe I need to switch them. So I could try that. Switch this to 10, switch this to 2. 2x times 2x is 4x. X times 10 is 10x. And in this case, we look at this and we're like, hey, that actually works, right? 4x and 10x is 14x. And so we could say that the factored form of this is x plus 2, the height of the box, and 2x plus 10, which is the width of the box. And that one actually works just as well. You look at the other one, these two right here. They look different, but actually they're the same. Because if I look at this, I could factor out a 2, and that would be 2 times x plus 5. So we have 2 times x plus 5, and then we have that x plus 2 out front. And if I multiplied this inside, then that would give me the 2x plus 4 that we had in the first place. So really we get two different looking expressions or factored forms, but they're really actually exactly the same thing. The advantage of the box method is that it helps us to think about area, which is really what multiplying is all about. And the only downside to it is there's a lots of kind of trial and error. We got to try a bunch of numbers out. Sometimes it gets frustrating. Sometimes we sit there. Whereas the X factor method is going to get you there efficiently, quickly, and easily every single time. Let's try another. What if we look at something like 6x squared minus x minus 12? Well, let's start with the area model. So 6x squared, there's lots of things that can give me 6x squared, like 3x times 2x, or 6x times basically 1x. So I don't really know which dimensions to put on there. But I do know this box is going to be 6x squared. And the bottom right corner is going to be minus 12, but there's lots of things that multiply to minus 12. Minus 12 and 1, 1 and minus 12, 3 and 4, negative 3 and 4, 4, negative 4 and 3, 6 and negative 2, 2 and negative 6. That's a lot of combinations to try, which means I could be at this for a really long time. So the key again is looking at this term, which is going to be a minus 1x. That tells me some information. After having done enough of these, I begin to get an idea that I want the difference to be between these two things to be small. And so I'm going to go for these two right here. And I want to keep my numbers pretty close together. So I'm going to probably try negative 3 and 4. I have actually no idea at this point whether this works or not. So we just have to try. So 2x by 3x, and I'll put a minus 3 and a 4 here. So 3x times 4x, or 3x times 4 is 12x, and 2x times negative 3 is negative 6x. Looks like I struck out. These together make 6x. So let's get rid of them and try something else. Let's swap, and so that one's out. And let's try negative 4 and 3. So negative 4 and 3. So 3 times 3 is 9x, 2 times negative 4 is negative 8x. And I look at those and, man, I'm really close. Because these two right here, they make 1x, but I wanted negative 1x. So what would happen if I switch those two around? Let's try that. I'll put a 4 here, and I'll put a negative 3 down here. So that's negative 9x, and that's 8x. And I managed to, fairly quickly, but it still took a minute or two, managed to figure out what that was going to be. So this one's going to factor to 3x plus 4 times 2x minus 3. Again, notice that I actually used a pretty minimum number of combinations, but I could have been at this for quite a while. Let's see a quicker way to do it, which is to use the x factor. If I approach this problem using the x factor, my first step is going to be to make my x. Again, the goal of this is to try to figure out these two numbers right here. And those are the two numbers that I'm going to split this into. So to start, I have 6 and negative 12. So 6 times negative 12 is negative 72. And I want those things to add up to negative 1, which is the middle term right here. So think about numbers that multiply to negative 72 and add to negative 1. I know that one of them, the bigger one, needs to be negative. And I'm thinking of 9 times 8 for my times tables. So negative 9x plus 8x. And the other two numbers just drop down, so 6x squared minus 12. And I look at the first two and ask myself what's in common with those. If I look at 6 and 9, I think a 3 multiplies into both, and they also both have an x. And 3x times 2x gives me 6x, and 3x times negative 3 gives me negative 9x. We'll look at the second two, 8 and negative 12. What's in common with those? I think a 4 is going to multiply into both. So 4 times 2 is 8, so 4 times 2x, and 4 times negative 3 gives negative 12. And as a reminder, those are being added. So we now have some common terms. Hopefully you notice that the like groupings here, or the like baggies as we refer to them in class. We have 2x minus 3's, and we want to know how many we have. We have 3x plus 4. And so you'll notice that I can pretty quickly and efficiently get to the same solution that I got to down here, just by using that x factor. All right, well, I hope that helps. Enjoy.